Hello, everyone. So today I am joining you with another lecture of my uh, course named as Big Data Analytics. And the topic we will be covering today will be uh, data analytics types, in which we will discuss about the descriptive analytics, predictive analytics, and prescriptive analytics. So here are our learning objectives in brief. So by the end of this lecture, you will be able to distinguish between the three these three types of data analytics, and you will be able to understand or explain as well the purpose and methods used and the output of each analytical type. And similarly, you will be able to identify appropriate use cases and industrial applications. You will be able to apply the analytics hierarchy to real world business problems, and critically, you will be able to critically evaluate which analytical approach fits a given scenario. So these will be the learning objective that we will be trying to achieve by the end of this course. So अगर हम इसकी एनालिटिक्स की हायरार्की को देखें तो this is how it looks like. So on the bottom of this whole process, the process starts with the descriptive analytics, and then comes the predictive analytics, which actually builds on top of descriptive analytics, and then comes the prescriptive analytics. So each stage or each type of analytics has its own significance. हर एनालिटिकल प्रोसेस की अपनी एक अहमियत है. फॉर एग्जांपल, descriptive analytics tells you that what is happening and what happened. So normally it is based on the past or historical data. These are historical facts, and descriptive analytics describe the data in a way that it tells you the story of the past. Then comes the predictive analytics, where actually we are forecasting or anticipating that what will be happening in the future. So that means whatever we have understood from our data, there's some event or some pattern or some incident has happened in the past. When we apply predictive analytics on the same data set, we are able to foresee or predict the future. That, okay, if we continue on this pattern, if we continue following the pattern that we found in the data, we will be able to achieve a certain thing or certain event or certain point or certain objective. Then comes the prescriptive analytics, where we are normally recommending and optimizing the decisions we have made. So in short, we are actually trying to say that what should we do? So that means previously we have understood what has happened in the past and what is going to happening what will be going to happen in the future, maybe tomorrow, maybe day after tomorrow. And prescriptive analytics tells you that what should be our actions in that particular scenario. So For example, when we want to achieve a certain level of a certain series of objectives that are built on some data of past, so that becomes descriptive analytics. So complexity wise, descriptive analytics is less complex, and the prescriptive analytics is the most complex in all of the three. So basically, you can see that it is a progressive framework where we are going for data-driven decision making. So this is like a pyramid. So if we look at the data analytics process flow, so this is the whole pipeline or whole process where we first of all we get the raw data. So we collect data, ingest data to different sources or sensors, and then once we have that data, then we go for data cleaning. So these two phases collectively are called as data cleaning, data preparation. Then it is followed by describing the data itself, which is descriptive analytics, which is our first type of analytical process. Then after that, we build on top of that and we predict the future, where we actually try to see that if the pattern in the data continues, what will be in the future. Just like climate change, people are predicting that we have 20 or 30 more years or something like this. So that is that is based on the previous or past data. Then comes the prescriptive actions. That means what should we do to achieve our goals in that particular scenario. So this is the type 3 data analytics. And in the end, we are actually making some business value. We are trying to achieve or we want to create some business value on the base of this particular data. So this is the whole data analytics process flow. So that means from our raw data becomes an actionable, intelligent workflow. So if we look at the comparison of the three, so the core question we ask, we have already discussed that what will happen, what happened, what will happen, and what should we do. This is the difference between the three. At a time, obviously, what happened is coming from the past or historical data. What will happen is for the future, and what should we do is also for the future, but it is action oriented. It requires some action. Then complexity, descriptive analytics is very low to moderately complex. Predictive analytics is moderate to high complex, and predictive analytics is moderate to high, and prescriptive is very high, highly complex. What are the key outputs for descriptive? It are the reports and dashboards. And for predictive, we have predictions and scores. And for prescriptive, we have certain plans or recommendations on the base of the prediction we have. Then the tools used for the descriptives are SQL, business intelligence tools, and Excel. For predictive, we have machine learning, AI, and regression. And for prescriptive, we have optimization and simulations. And when we talk about business value for descriptive, it gives us the understanding and it makes the reporting easier. And for predictive, we can assess the risk and opportunity. And for prescriptive, we can achieve actually decision automation in our processes. Now, let's discuss in detail about the descriptive analytics. What happened? So basically, it is the most fundamental, it is the foundation of whole analytical process in which we actually examine the historical data so that we can summarize past events. We can actually identify the trends in the past, and we are able to generate insights about what has already occurred. So, everything about the past. So, in this, actually, we are transforming raw data into some meaningful summaries so that stakeholders can understand that what has happened. So, it if we look at the core methods and techniques, so there are statistical summaries like mean, median, mode. These are the measures of central tendencies. Then we can measure the measures of dispersions like variance, standard deviation, range, interquartile range, and then there are frequency distribution and histogram. So these are all statistical summaries that are our core methods. Then there are data visualization techniques to showcase the data of the past. For example, trends of the past. For example, bar charts, line graphs, pie charts. Heat maps are very good in time series data and geospatial maps. Then we have interactive dashboards like Power BI, Tableau, Google Looker. And then there are some certain reporting mechanisms um, where we have some KPIs, key performance indicators, reporting, balanced scorecards, and executive summaries, and OLAP cubes. So these are all the mechanisms, core methods, and techniques used in this process. The industrial applications are very wide. For example, retail. In retail, we can actually go for monthly sales summaries, customer purchase history. Healthcare, we have patient admission rates, disease prevalence, dashboards. For finance, we have account activity reports, transaction volumes, summaries. Manufacturing, we have production output logs. For education, we have student performance tracking and enrollment trends, etc. And obviously, it has certain limitations as well. The first limitation is obviously we are always backward looking only. That means we are only looking on the trends of past. We cannot predict or optimize future outcomes on the base of these techniques we use in descriptive analytics. Um, so correlation was versus causation. Pattern observed may not imply causal relationship. Uh, we can somehow see the relationship between the two or two or more variables, but we cannot. Uh, it is very hard to predict the causal effect. That means which uh, event or which variable has caused which other variable. So data quality independency, that means biased or incomplete data, which actually leads to misleading summaries. And obviously, it lacks prescriptive guidance as well. That means we can identify what is happening, but why it is happening, it is hard to identify from the information or the techniques used in the predictive analytics. Then the next type of data analytics is the predictive analytics. That means what will happen. So it also uses the historical data, and we have some statistical algorithms and machine learning to forecast these the future events. Uh, but we are not actually relying on the past uh, reporting only, performance reporting only, but we are actually trying to estimate the likelihood of a future event or outcome that is evident from the data. That means we have understood about from the descriptive analytics that something has happened in the past. Predictive analytics give you the possibility or opportunity to estimate that what is the likelihood of the same event happening in the future. ठीक है, तो व्हाट इज लाइकली टू हैपन, तो पास्ट में जो भी हो चुका है वो आप प्रेडिक्टिव एनालिटिक्स में जान लेते हैं, लेकिन प्रेडिक्टिव एनालिटिक्स में आप लोग ये जानते हैं कि फ्यूचर में क्या होने वाला है ऑन द, और उसी पास्ट या हिस्टोरिकल डाटा की बेस पे. सो इसकी व्हाट इज द पाइपलाइन, प्रेडिक्टिव मॉडलिंग पाइपलाइन लुक लाइक हाउ. सो फर्स्ट ऑफ ऑल वी कलेक्ट डाटा on different databases, APIs, or sensors. We pre-process it. That means we clean it, impute it, or encode it, or scale it. Then we actually go for feature engineering. In feature engineering, actually, we select certain uh, features, number of features, or types of features, or transform the features and maybe creating new variables from the existing ones. So this is what we do in the feature engineering. Then we go for model training and then for evaluation, both of these parts of the machine learning paradigm. And then once we are satisfied with the evaluation, we go for a deployment and monitoring process. So this is the overall modeling pipeline in the predictive analytics. So core algorithm in statistical model, we normally use linear and logistic regressions. For time series, we go for ARIMA or exponential smoothing. For decision trees, random forest and gradient boostings are very popular algorithm in the for general predictive analytics. SVM is neural networks and deep learning are popular for the more complex data sets. Evaluation matrices that we use are for classification. We normally use for go for accuracy, precision, recall, area under curve. For regression, we normally go for root mean square errors and R square errors. So there are many industrial applications. For example, in banking, we go for we can predict about credit scoring, fraud detection. Healthcare, we can predict the outbreak, disease outbreak. For retail, we can predict the demand or forecast demand of a particular product. And then for telecoms, we can actually see that how when network failures can occur. For insurance, we can actually claim certain. We can actually model that what is the probability of certain claims. So these are industrial applications. So what are the key challenges in this particular type of data analytics? So first of all, overfitting. So that means the model performs very well on the training data, but it performs very poorly on the unseen or new data. Then there is a requirement of data itself, that we must have a very good data set in which we have large or high volume, high quality of data present. And then explainability of the models and the results derived from the model is also a big problem. Then there is a concept drift. That means real world distributions shift over time, so our accuracy degrade. Then there are ethical concerns. That means we are biased in the training data, and it can propagate unfair predictions. Then comes the third type of data analytics, that what should we do? That means it is kind of a recommendation. So it is the most advanced tier of data analytics. It only focuses on forecasting the future outcomes, but also recommends specific actions that are required to achieve certain objectives. So the core methodologies are linear programming, where we are doing resource allocation under certain constraints, integer and mixed integer programming, where we are going for discrete decision problems, and then multi-objective optimizations are very popular, especially when we are balancing the competing goals. Simulations techniques are which are very popular in these kind of optimizations are Monte Carlo simulations. That means modeling probabilistic outcomes under uncertainty, discrete event simulations, and agent-based modeling. So discrete event simulation is about modeling queuing systems, logistics flows. So we also have AI-driven decision systems where we have reinforcement learning systems that learn optimal actions via reward signals. Um, so expert systems and knowledge graphs are also there. Decision automation engines and rule-based systems are also present. AI-driven decision system. So industrial applications in airlines, we can actually predict about dynamic ticket pricing. Um, However, pricing should actually change according to demand. And then logistic actually route optimization for healthcare, patient assignments on patient assignment recommendation. The patient which are in critical condition should be given priority. Then in finance, automating the automated rebalancing. And in retail, we can actually go for AI-driven markdown or replenishment strategies. Where we know so that we do not go for overstocking or stock out. What are the ethical and implementation considerations? Human oversight is always good for these kind of systems, but because complete automation means that humans are out of that process, and it may result in the loss of life as well. So these systems are not optimized, cannot be actually considered error free as well. So transparency, the CN logic must be explainable and auditable. Whatever AI system or the CN support system has given you the solution or strategy, it must be explainable or it can be audited later on. Fairness and communication costs are also very important implementation considerations. So when we talk about now the side-by-side comparison of the three, so here is the overall um, comparison of the three, which we discussed. Um, so if you look at the time, we have already seen that it is from the descriptive is from the past, predictive is for the future, and prescriptive is for the future actionable. And data needed is structured and clean for descriptive, and for predictive, it should be labeled normally and large. And for prescriptive, it should be real and rich and of high quality. Um, so automation, if we look at the automation for prescriptive, it is the highest. And business return on investment is that prescriptive provides the most value because it automates the decision. And use cases are also there. For example, for descriptive sales dashboard, KPI reports. For predictive, there are churn predictions, demand forecasting. For prescriptive, there are route optimizations, drug dosing, and portfolio management, etc. So these are some of the terms that we have used in the lecture that you can actually, so that you can understand the whole point. So that's all for today, and hope to see you again. Thank you. Bye bye.